In this video we are going to explain the topic sectors of circles, and it's based on text and test 5. So a sector of a circle is basically a section of a circle. So this pizza slice, for example, is a sector of a circle. Here we have some revision of circles. This should be prior knowledge from your junior cert. The perimeter, often known as your circumference, is L. In your log tables it's given to you as L, and L is equal to 2 pi r. So the circumference is equal to 2 pi r, and your area of a circle is equal to pi r squared. And then we have this fact, and it is actually a theorem. A cyclic quadrilateral is a quadrilateral inscribed in a circle. So basically, you have a circle, there is your circle, and a cyclic just means a four-sided shape in your quadrilateral. I'm going to make sure now all of these four sides touch. I'm going to do it a little different. Making sure all the four sides touch your circle. I'm going to just move this one there, so now they all touch the sides. That is a cyclic quadrilateral. That's all that means. It isn't actually touching. Up here we need it to touch all four sides, so there, that's a cyclic quadrilateral. It's in your circle and it touches in four places. Another cyclic quadrilateral could be that one or this one. It's a four-sided shape in a circle. Then we have another theorem there. Every triangle inscribed in a semicircle is a right angle triangle. That is a very important theorem. So again, we have a circle, and it's not talking about a full circle, it's talking about a semicircle. So that's actually a nicer way to phrase it is any triangle made with the diameter of your circle. So we have a diameter there, and any triangle made now using that diameter is a right angle triangle. So that's a right angle triangle. This is a right angle triangle. This is a right angle triangle. If it touches your circle in three places, and this being one, and this being one, it is a right angle triangle. That isn't, it should be spot on the edge or your circumference. So another way it could be on the bottom semicircle, you could have that triangle, it is a right angle triangle. And you could have this triangle, it's also a right angle triangle. This is also a right angle triangle. So I think you get the idea. That is also a right angle triangle. Anyway, and now 360 degrees is equal to 2 pi radians. You might know that from trigonometry. Pi is 180, so 2 pi is 360. And now, the arc of a circle. So if we look at this diagram here, we have a minor arc. Minor is smaller, major arc is the bigger arc. And you could call this 2 points, and you'll see this in some of the questions. So you have an arc from A to B. Well, is it the minor, which is the smaller one, or the major from A to B? And if we want to calculate the circumference just of that arc, well, it's going to be a portion of the whole circumference, and it's actually going to be whatever that angle is. It's that angle over 360 of the smaller of the circumference. So that gives us this formula. This is 2 pi r, which is your whole circle, but we don't have the whole circle, we have a portion of it. So that is going to be, we have what's the angle out of 360 of your circle. So that is what happens there. You get this formula is in your log tables. Pi r squared, the degrees over 360, or in radians. What happens here is 2 pi cancels with 2 pi and you're left with r theta. So that is also in your log tables. This is in your log tables. Area of a sector Well, the area formula is pi r squared, and again, we don't have the whole circle. For example, if I want to get that 60 degrees, we'll say, we want the area of this coloured in section here. Well, that's going to be, if our radius is 5, we'll say, the area of your sector is going to be pi 5 squared. But we don't have the whole circle, we only have 60 over 360 of the circle, and then you calculate that in your calculator and you get the area, and it's units squared because it's area. That's it, that's all it is to it. And the same thing with the radians, the pi and the pi cancel, so you're left with a half multiplied by r squared theta, and this is in your log tables and this is in your log tables. So that brings us to the first example. A flower bed in the shape of a section of a sector of a circle is placed in the centre of a rectangular lawn and is shown in the diagram. Calculate I the length of edging needed for the flower bed. So the flower bed is this part here. I'll use a different colour. We would need to calculate that part and this curved part, and then add on 5 here and 5 here, because that length is 5. So what we're going to need to do is we're going to have to get the length of the large circle, the length of the large sector IH, and I have the formula there, 2 pi r theta over 360, because we're dealing with degrees. Do we know the angle here? Well, we do. And if we zoom into that, we can see there's a little box drawn in there, so our angle is 90 degrees. So we have 2 pi, or is of this large sector, 5 plus 3, which is 8. The radius is 8, and then theta is 90 over 360, and we'll put that into your calculator and you find that it is equal to 4 pi meters. And then the length of the smaller sector, the radius of the smaller sector is 3, 2 pi by 3, and the angle is the same, and that is equal to 3 pi over 2 meters. And now if we get the perimeter of the flower bed, we just have to add 4 pi with your 3 pi over 2, and we have to add 2 5s, which is 10, and all of that's meters, so I'm going to put that in a bracket and meters at the end. When we add all of them together, we find that it is 11 pi over 2 plus 10, which is equal to 27.3 meters. So that would mean the edging required is 27.3 meters. And now if we go back up and read part 2, find the area of grass in the garden. So the logical way to think about this would be, if I find the area of this sector and then find the area of the smaller sector, subtract this, and then I'm left with the area of the garden, which is this bit, and then the area of the grass is going to be the whole rectangle, take away the area of a garden. Even just looking at the rectangle, do we know the dimensions of the rectangle? Well, this length here is 8, so that means this length here is 8. So this length here is also 8, because this is the radius of your sector. So that means this is 8 meters. And then the bottom part would be 16 metres because it's 2/8. And that is crucial to help you solving that question. And now we'll work on finding the areas of the sector. So, area of the large sector minus area of the small sector equals the garden. So I'm going to fill into this formula. We have pi r squared, the large sector r is 8, and 90 over 360 minus pi 3 squared and 90 over 360. And that gives us 43.197 metres squared because we're dealing with area. The area of the rectangle was 16 by 8, which is equal to 128 metres squared. So your area of grass is 128 minus 43.197, which is equal to 84.8 metres squared. And that's the end of that question. Then we'll go on to look at question 2. So question 2 here, I have question 2 here, I had it done out previously. So the minor arc CD of a circle, centre O and radius 20, subtends an angle X. So the first thing I would do there is draw that out, as I've done here. It's a lot easier to picture information like this when you have it as a drawing, and oftentimes you get marks for your drawing. So the major arc CD subtends at angle 5x radians at O. O is your origin or your centre. Find in terms of pi the length. So I have the formula there for length. And the next thing we want to find length, and to put in length we need the radius, which we have. We also need the angle, which we don't have. But we know that x plus 5x is equal to 360 degrees or 2 pi. We're going to work with radians because it says in terms of pi. And that would tell me that 6x is equal to 2 pi. So x is 2 pi over 6, or a third pi, or pi over 3. So now we could find the length. Length is 20 centimetres by pi over 3. And when you put that into the calculator, you just get 20 pi over 3. So that would be your length in centimetres. And I had a note that this is an exact answer. You might be asked for an exact answer at times. It would be an approximate answer if we started rounding it to decimal places. But when we leave it in terms of pi, that's an exact answer. So thanks for watching. I hope that will help you do the sector and area of a sector questions.